What is up, you guys? My name is Max, and in this video, I'm going to show you how to solve first bad version on LeetCode. So in the problem description, it says that we are a product manager, and we are working with a team to develop a new product. However, the latest version of our product fails our quality check, and since each version is based on prior versions, that means any versions after the one that failed the quality check are also bad. So for this problem, it says, suppose you have n versions of a product you're developing, and you want to find the first point of failure that causes all the subsequent versions of your product to be bad. And so they give us this API that returns a Boolean value. When we pass it a version of our product, it'll say whether it is bad or not. And we can imagine that this API call is expensive. It takes a lot of time and memory to do a check on our product version. So we want to minimize the number of calls to that API. So in this example, let's say we have 5 versions of a product, and looks like the bad version is 4. So we would want to output 4 because that's the first bad version, the first point of failure. But what our function would look like is it would call our API. So it would be, let's just say it checks once, it will return false because that's before the bad version. 5 will return true when we call the API because that's after the first bad version, and 4 is the first bad version, so it'll return true. And this guy right here looks like it's just one version of a product. The first one's bad, so we return the first version. And so the way I'm going to approach this is I'm going to whiteboard a little bit in MS Paint, and then I'll hop into VS Code and debug and show you guys how I solved it in JavaScript. So to hop over to MS Paint, the first way you could think of this problem is if you have 5 product versions, that's pretty much just like this array. We have the first, the second, the third, and so on version of our product. So the first way you could approach it is you could just iterate over that array of product versions and call the API. You call the API here, you say, is this one bad? Nope, it's not bad. You call the API again, call it again, you call it again until you find the first API call that returns true. But that wouldn't be very efficient. What we could do, since this is basically an ordered list, is we can implement binary search and find the first point of failure. And I'm going to show you how we do that. So in binary search, essentially you have this start and end pointer. And while start is less than or equal to end, we are going to implement our binary search. So to do that, we would take the starting pointer plus the starting value plus the ending value, divide it by 2, and floor that to get our midpoint. Essentially here, we would make an API call and say, hey, is this version bad? And if it isn't bad, and also keep in the back of our minds 4 is the bad version from our first example, it's going to return, the API is going to return false. And so that means not only is we don't have to check this version anymore, we don't have to check any of these versions prior to it. Because we know that this version is based on the other versions of our product, so it's good. And you can kind of think of this as like if you're looking for someone's name in the phone book and you're checking last names, like let's say their last name starts with M, and you're searching like in the C. Once you check C, you can already immediately eliminate the rest before that because their last name is the last letter is greater than C. Pretty much. So once you determine that 3 is good, you don't want to even check 3 or anything before it. So you just move the starting pointer. Boom. You move it here to mid plus 1. So here you calculate the midpoint again. And you'd say, all right, 5 plus 4 divided by 2, we floor that, we get 4. All right. We make a call to our API and say, hey, is this a good or bad version? It returns that this is a bad version. And so in that case, we would move the ending pointer to our midpoint minus 1. But in this case, we said we were only looping while the start is less than or equal to the end. So that means that we've already found our first point of failure because end is less than the start. or start is same thing. Start is greater than the ending pointer. And so I'll show you how we could implement this straight up in JavaScript. So if I hop into my VS Code, I kind of just copied over the solution and the inner function, and I wrote my JavaScript code here because we're writing the function that calls the API. What I did was I basically made my own test API, and it takes in a version of a product, and it just returns true if the number is greater than or equal to 4, which means 4 is our point of failure. And we're doing the same example I showed in Paint, where we have 5 versions and 4 is the point of failure. So let's get started and start debugging. So first we will initialize that solution variable and pass it the API. Then we are going to call the inner function with this parameter 5. So we have n is equal to 5. We have 5 versions of a product. The starting point is then 1 and the ending point is 5. And we're going to check using binary search where the first point of failure is. So we calculate the midpoint and then we call the API. And so we call it on that midpoint. We say, hey, is 3 a bad version? And it is, I stepped in, it is going to not return true. So we would take the starting pointer and move it past that midpoint because we don't need to check anything to the left anymore. We just want to keep honing in until we find that first bad version. So we go and we iterate again. We have our start is at 4 and end is 5. We calculate the midpoint, which is then 4, and we make a call to the API. It's going to return true because 4 is our first bad version. We then reposition our ending pointer, and now start is greater than end, so we are going to stop and return the start. And essentially that would be 4. And that's what we're looking for. That's the first bad version. If that didn't make any sense, basically, if I were to, all right, so here the starting pointer will always be ending on where we find the first point of failure because it basically exits the loop at that point. So we know that this guy was the first bad version. So let's go ahead and paste our solution into LeetCode and see how it does. All right, so we will paste our function for calling the API here. We'll run it on the first test case they have. We get the expected answer. We'll submit. And boom. So for this problem, it seems that the time complexity would just be the time complexity of binary search, and the space complexity, we honestly just need to store these 2 pointers here. So and mid would also have to be in memory. So it'd be a constant time pretty much for any array of product versions that is given to us. So that is the solution for first bad version. I hope you enjoyed, and I hope to catch you in the next one. All right, see you guys.